Greetings. This will be a short show and tell video on the Glowforge Focus Height calculator. But before I get into the meat of the subject, let me touch on some basics. For those starting out, typically you've got something relatively thin that you're working with as material that's laying on the crumb tray, and you're using the Glowforge to be creative. As long as that material is less than 1/2 inch thick, you're good to go. The focus height is essentially the thickness of the material that you're working with. What gets to be a challenge is when you finally graduate to the point that you have decided that you're going to work with something which is thicker than 1/2 inch. You're going to have to put the material on the floor of the Glowforge. The challenge, however, is the top of the material that you want to work with has got to still be as high as the CrumbTray surface used to be when the tray was installed. So that means you're going to have some sort of shim material underneath the item that you're working on in order to raise it up such that the top of the material being worked is above where the crumb tray surface used to be. The way this is typically done is you look around and find a bunch of scrap material of projects that have been done in the past, and you put several sheets of whatever together, which you figure is going to be high enough to raise the item that you're working on high enough so the top of that is above where the crumb tray used to be, and now it will live in the sweet spot where the laser can get to it. But you still need to know two key items. One is the thickness of all of the shim material that you pull together to raise the working item up a little bit. And the second is the material thickness, but that value has to be calculated from the distance where the crumb tray used to be to how far it extends above the crumb tray now. This is where the calculator comes into its own, because it will do the calculations for you and give you the focal height value that you need to plug into the Glowforge setup in order to give the exact focal height necessary for the laser to work the material that you've selected. Something you need to keep in mind before we see this calculator actually do its thing is in the folder along with the calculator program itself are a couple of text files. One is a text file called CrumbTray Height, and in that is the value of how high your crumb tray is from the Glowforge floor. It'll be somewhere around 1.36 inches, since all of them are pretty close to being the same, but you really need to measure your particular Glowforge to get the exact value. The second text file is a shim height.txt file. I'll get back to that shortly with an explanation. Okay, let's take a look at this calculator in action. Once you launch it, you got two major pieces of information you need to provide. One is how thick the material you're working with is, the stuff that you're cutting, and the other is how much shims, the thickness of all the shim material that you're using to raise the material you're working on into an area that can be processed by the Glowforge. In this case, let's say the thickness of the material that you're working with is 0.748. You get that entered in there, and all of the scrap material that you pull together as shim material, you measure that, and let's say that comes to a value of 7.82. So once you're armed with how thick the shim material is, go ahead and enter that into the calculator. Hit the calculate button, and the utility will calculate the focal height value that you need to plug into the Glowforge setup in order to have the laser focused exactly as you need it to be. Okay, this approach is probably the approach that's used by most folks when they're working on a project that's too thick to be able to be used with the crumb tray in place. Another approach, which I think is a little bit better, is that instead of grabbing random shim material of varying thickness, putting a stack together and then measuring how much you got, consider the option where you have a collection of shim material set aside, where each shim material is the same thickness. That way, if the calculator was aware of the thickness of a single piece of material that's used for shimming, then it could calculate for you how many layers you need to use in order to raise your item up into the sweet spot where the laser can focus on it correctly. And that's what we are doing in the next shot. I'm sure you were thinking when I said shim material, board, acrylic, materials that you've been using to cut with on the laser. What I've been working with lately is this collection of magnets. Interestingly enough, each magnet is a nice, consistent 0.2 inches high. By defining the shim height in the shim height.txt file, which is in the folder with the program, the utility is now in a position to be able to calculate and tell you how many shim layers that you need to use with this particular project. I like using the magnets as shim material over old pieces of plywood or acrylic that were used in the past to cut something with the Glowforge, because the magnets don't have an issue of bowing and not being exactly flat. Additionally, they provide a very sturdy column on which to put the piece of work that you're planning to use the laser on. To set up the calculator for when you are not planning to manually enter the shim thickness, the only entries you need to do is give it the thickness of the item that you are planning to work with, In this example, we will use again 0.748. Only in this case, you do not enter any value in the shim thickness box. Leave it blank. Click the Calculate button, and it will say for an item that is 0.748 inches tall, you need 4 shim layers, and the required focal height value is 0.183. Now that's pretty much it in a nutshell. Using this utility, I have found that it is fast and accurate. You only need essentially 2 pieces of information in order to get the focal height that you are needing for the Glowforge setup, the thickness of the item that you are working on, and the shim height. Those two, whether you use the magnet approach or a collection of stuff that you measure, either one will work for you. And I've found that using the utility is certainly faster than doing it the old-fashioned way.